Right, for my next trick I'm going to be looking at this rather old Sharp video camera. It takes the old it's not Super 8, Video 8 tapes, I believe, and has a independent camera on the side there, so you can sort of hold it at any angle and yeah, get a good look at what you're doing. And yeah, it has the cassette in here. Now there should be an eject button somewhere. Where did I see it? Ah, it's hiding down the side. This is where the tape is stored. The whole mechanism comes up and pops open, and look at that. Magnetic digital. None of this SD card rubbish. Pure unadulterated signals on tape. The mechanism in this seems to be in pretty good condition, which is saying something for something of this age. But the problem that we are facing is that it won't focus. It's stuck, and stuck in macro by the look of it. Put my hand in there and it actually it looks somewhat good close up, but anything past about 5mm from the lens is hopeless. Now, to get this thing apart, we're going to have to take the main body apart so that we can get in there and perhaps better access. I don't know how many screws are holding this cover on. There's one there and there's one at the top there. Oh, actually, we might be able to get away with it. There's two on the bottom, one on the side there. And if we spin it right around, get one on the top there. You know what, I'm going to be lazy, and one on the side. I'm going to be lazy and just start picking away at the screws on this. I don't really want to have to pull the body of this thing apart. I don't know if the focus issue is going to be in the camera head or in the control system. But we'll find out. The zoom, I think the zoom works. Can't remember if the zoom worked or not. But I think it did. It was just always out of focus. Right, I've got all the screws out and I have to hand it to the engineers for using all the same length. Makes things a lot easier. So it looks like it's going to come apart at the seam right there. That's the back with the buttons on it. Yep, there's a flat flex going up there. Can I take that off? Is that just a push in? I think it might just push in. I'm going to give it a little bit of a tug and see if that comes out of there. Ooh, jeepers. Old technology, flat flex. It feels like paper. I feel like it's just going to tear in my hand if I pull on that. The only way to get in there, I think, is going to be to take that off, which is going to be glued from the front, perhaps. Where's my prying tool? Right, I get my tool under the edge there, and it does want to lift with a couple of popping sounds. Something's letting go. Was it glue or was it plastic welded and she'll never go back together type? Let's see, what do we got there? Oh yeah, oop. Lots of little plastic tabs that look like they could have been somewhat permanent, but it's all one piece through the back there. So okay, so you can see, if you can see, down in the bottom there, you can see where the membrane comes in at the bottom, the blue, it comes in the bottom there, and it's actually that flex. Oh, it's all under those buttons. The whole piece is one piece, flex included. It doesn't actually unplug. So yeah, no worries. We can glue that top cover back on if it's necessary. Piece of cake. What that does mean for the rest of the head, on this camera head here, it would have been ideal to perhaps remove it. Well, actually no, if I look down in there, you can actually see a screw just right down in there. So it wouldn't be removed from the inside after all. It would all be it's all done on the outside here and attached after the body's assembled, because that screw is holding the pivoting bracket together. Have another screw down here, and that should release the rest of the plastic case. It appears to have a leg going down there. There we go, that's come loose there. What else is involved? There's all the focusing mechanism. You probably can't see just yet, but down in there, let's have a look. Down in there, there's a little motor. You can see these solder connections here go to a motor. That's going to be a motor for either the focus or the zoom. With the image sensor board, that's the image sensor board on the back of the lens there. Actually, it looks like with that screw undone that the whole assembly might come away from the pivot joint there. Let's see if I can get a closer look. I have found it. The other screw is holding me up right there, and I can't get access to it the way this pivots without opening the front cover. Now we've got that off. I think the whole this front piece here, or is it the back part, will separate. I think it's the front part will separate. There we go, the front part with the front lens, which is just a clear bit of glass. It's not altering the image at all. It's just a clear protector. And that exposes the front part. Ah, there we are. There's our other little stepper motor that will be doing either zoom or focus as well. I don't know if this has an iris or if the brightness is done digitally, but sometimes there's another one in there for actual iris control. So where to from here? It appears that that's almost going to completely come away from the tilting frame, and one more screw at the bottom that was hidden by the front cover. Okay, and here we go with the front cover off and the last screw attached. We are all free. Now we've got some flex cables, a couple of flex cables that we'll need to disconnect. We can see the blue one we saw earlier comes through to the front here, where it does appear to be just a plain old press fit connector, so there's no release tab. It's just a snug fit, so I should be able to remove that. Probably a service manual online for one of these, given how old it is, and there tended to be information, useful information like that for older electronics, not like these days when everyone's trying to cover their ass and hide their secrets. Right, so what I can hear when I turn it on is the sound of it sounds like a little motor trying to turn, and it's constantly trying to do it, like it's trying to move it, but the response isn't what it expects, so it tries again and again, and it's just buzzing repeatedly with a pause in between. And you can see here's our motor here, and we've got 1, 2, 3, 4 terminals on the top there, and I could very faintly hear it, and what I did was putting the screwdriver on the end of it and put your ear up to the other end. It amplifies it so you can hear it a bit better, which helps pinpoint which motor it was. So I touched that motor and the one over the back, and yes, there is one further in the back there that I'm pretty sure operates the shutter, and that is working, and it flicks on and you can see it move when you turn the thing on. Yeah, so what I'm going to do, just to prove this motor is the one that's trying to be driven, because I think what's happened is somehow the mechanisms got jammed up inside. It's possible it was dropped, or some impact that caused that, but maybe it's just dried up and gone horrible in there. I don't know. Maybe a gear's broken a tooth and it's just jammed up. Probably more likely. But anyway, what I'll do is point you at the oscilloscope while I probe these pins up here, and we'll see if there's any signal on them that proves that it's trying to be driven. I'm not too sure what signal level to expect here, but let's probe on there. Oh, look at that. Let's try the other one there. Alright, similar amounts of hash. Let's see if we can tune it in a bit better. So we're looking at about 1 volt, 1, 2, 3 to 4 volts peak. They look like some kind of a square wave, I guess. See if it changes with our zoom buttons at all. No effect on those ones. Alright, let's probe the one over the back there and see what that if that has anything on it. It has nothing really. Okay, got that other lead there. No, still a lot of nothing. So I'm not too sure what that motor does, unless it's trying to find some zoom position, and it's not achieving it, and so maybe once it finds its zoom position, then the focus might activate. The one at the back could be the focus. Not too sure. I'm guessing then that that's actually going to be some sort of drive. It is actually trying to drive that motor. I'm thinking that's then that the mechanism must be jammed up. That's going to be fun to take apart, but I think it's the next port of call. You can just barely see that. You can see it jumps up another volt when it gets louder, so it's floating around 1 to about 3 volts when it comes down to the center line, and then 3.5 volts, almost 4 volts actually. It's almost, and then it jumps up to the almost the 5 volt mark when it makes the noise. So it's going, it's buzzing with a pause. Almost every second there's a buzz. 1 second there's a buzz, and that waveform peaks every time it does that. Removal of the unit simply meant unplugging, look, I guess it'd be a power feed and the 2 flex connectors that come in here, and it just comes away once all the screws are out, of course. And what we want to do is get this head off, and to do that We have a flex at the back for the CCD down the bottom of that board there, so we'll get that off. Just connect a locking tab, just slides down on each side, and that should just pull out of there. Nice and gently does it. And then we've got screw, 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 and they're on a rubber mount. And then once they come out, there looks like another flex underneath, and we're in. Got the screws undone, and it looks like they've kindly supplied us with a huge length of flex there. That enables us to get in and decouple it without everything being in the way. So there we have one motor, two motors, and this one in the middle will be our shutter control. How to get in there? Well, it looks like the motor's attached to this metal plate, and I'm thinking if we take this metal plate off, the motor might come out and leave the whole gear assembly intact. It looks like I've just lost a little washer of some sort. I wonder where that came from. Might make itself apparent at some point. There's nothing obvious. Here we go, here we go. On the bottom of this rubber mount, there's a little washer stuck to it. And it looks like, yes, there's one left. Okay, they all go on there, but there's one still stuck in the casing. So that's 1, 2, 3. Might pull that off before it falls off and I lose it. So what I'll do is go for that screw there, and that one there. Watch where all the springs fly, huh? You never know how they've assembled these. Here we go. Right. Okay, so there we can see a worm gear, very fine one at that. And that just pulls this back and forward to do whatever it does. That well, that'll move one lens back and forward, I guess. But that's fine. I probably should have gone for the motor at the top, because that's the one making all the noise. That's the one that could be stuck. But I'm not too sure what it's using for positioning info. Usually it knows where home is. There could be... it doesn't really look like the flex goes to anything that might indicate such a thing. Probably here, this would be a photodiode, actually a little optical gate. That's what it'll be, and it'll know home is there because it'll break the beam, and that'd be it. Okay, I might just grab hold of that and see if it moves very carefully. Oh, that's free. That's not jammed at all. What is it? Is that moving anything obvious in the lens there? Oh, yep. Oh, that's whether that's zoom or focus. I think that'll be zoom. Rotate the motor and make sure that's not stuck. Right, just grab that. Oh, that spins freely. Nothing wrong with that motor. Right, we'll put that one back together and try for the top one. Now, in order to get the flex out of the way of the other motor mount, I've had to remove the shutter actuator, and it's a very delicate mechanism, but I'll see if I can activate it. It'll pull. That pulls up, that opens up. It may be used as an iris-like function for light reduction, but as far as I can tell so far, all it does is just pull that open, completely open, and shut it off. Rightio. What's behind door number 2? Alright, does the motor turn freely? Yes, it does. Does our sliding mechanism move freely? Yes, it does. Oh, it's not a good start. That tells me, yeah, that's probably focus. There's a little one in behind there that's moving. Probably can't really see that. Anyway, it's definitely moving freely. Not a problem there. Alright. It's possibly a controller issue. Interesting. So here's the other part that the camera module sits in here, and I'm going to hazard a guess that the circuit under here is what's responsible for managing the zoom and the focus. The buttons on the other end for the cover we pulled off, that's our zoom control, wide and telephoto, and that goes straight into this board, and that would directly be controlling the zoom motor. And when I was pushing that button with the scope on it, there was no obvious change in signal in any of those, so I'm thinking this board is likely to have a problem now. The CCD signal comes into this board. I'm picking, I don't know if there'll be much processing of that signal on this board specifically, or if it's feeding the two flexes that go in here. There's two flexes in here that go back to the main board. This one goes to the camera module. That'll be the this one goes to the CCD. The motor control is the larger flex that went in the side down there. That's right, there we go. Right, so to start with, I guess we should see if there's a reasonable voltage at this plug here. This is obviously going to be power. I guess we should look at that and see if it's fluctuating, if it's some really weird number like 7.3 instead of something you might expect like 5 or 12. So it turns out that that lead that I thought was power is actually not power. It's a switch that is on the rotating mechanism, which I think determines whether which position the camera is rotated to. So it would appear that the power comes in this flex here, and the obvious giveaway is the large traces for current handling capacity. So with the unit turned on, we'll have a measure around and see what we can see. So we'll go for some nice big capacitors. We've got 4.3 there, 3.6 there, 1.1, 25 on that one, 4.7, 3.1, 4.7, 1.9. So yeah, a variety of voltages there. No obvious indication as to what they should be, however. Now we'll check the crystal and see if we've got anything happening there. And we've got a frequency of 28.3743 megahertz as measured by the scope. It's 28.375 on the crystal, so that's fine. So here's the connector for the motor drive, which look like test points that they usually leave out. They go to this IC here. Now I can't find a data sheet on it anywhere. Something with a similar number suggested that it might be some kind of RGB encoder. So I really don't know what's going on there, but the only data sheet I can find that says RGB encoder is actually more in the style of one of these, a dip package. So unless they've combined maybe an RGB controller into a motor drive and what have you, and packaged it all into one for this, but I doubt it. Who knows? So it is getting warm, even though it's not driving anything. It is getting warm, and I'm wondering if the power supply might be clean to it. I've noticed some very baby inductors around the place that appear to have a switching like action on them. So whether they are local voltage regulation, I'm not 100% yet, but it's possible. So perhaps we have a probe of the voltage rails into this IC and see if it is see if it's clean. Okay, we're at 2 volts per division here at 2.5 microseconds. I'll turn the thing on and we'll start probing with the corners. I don't know if that's a standard that they use. There we go, so we've got 1.9 volts there, 1.9 volts there, nothing there, 2 volts there. Now that looks like one of the motor outputs, 2.9 volts there, 2.9, whoa! And whatever that's supposed to be, that's all over the place. I wonder what that's supposed to be. If I were to use my digital multimeter, just out of curiosity, it's saying 4.3, which would be like an average type voltage reading. And if we go over to the top side of the board where all the capacitors are, and let's probe some capacitors in the general area of that IC, because it looks like all the voltage regulation is done on the top side there, on the other side. So we'll start with some nice big capacitors. That one's, oh yeah, okay, so that's 3.4 with a little bit of noise on it. Here's one of the little white ones, which is 4.6. That one's 2. Nice big capacitor with that on the end of it. Now I'll show you where I was probing, and this was the first one I probed, and it was that one there, and these two down here, and the one with all the noise on it is this big black one at the bottom. And if you can see in the camera, it's actually a little more discoloured. It's actually quite discoloured, and there's even a bit of warmth there. So I'm picking maybe that capacitor's failed and is making the whole rail noisy as hell, and that's probably generating excess heat in the IC as well. Now I haven't got exactly this style of capacitor, but this appears to be 15 microfarad at 10 volt. If I go by the number on it, this one here is also 15 at 10. So a quick and dirty way to check the capacitor would be to swap them and see if this rail cleans up. And if it does, we know we're onto something. Also, I will pull that out and measure its capacitance. That would be also an obvious indication. In fact, we might as well just do that instead of swapping them. If it measures bad, it's going to be it. If it measures good, we can scratch our head a bit more. Now out with the old hot air gun, grab something to grab hold of it with. Okay. Just warm it up from a distance. Notice a lot of people who use the hot air guns don't really talk about how they're using it, and I still haven't got it perfect yet. Because what I was doing is I was running it at quite a low airflow because I was afraid of blowing things off the board, and had it right down on very low, but I had the temperature right up so that I could get as much heat into it as I could, or so I thought. But I think what was happening was I was just heating the surface and scorching the surface, and it was still taking a while to get the solder liquid. So what I've done is drop the temperature and increase the airflow, and I think that works quite well. And so the airflow I've got up at about 1/3, a bit under a half. And I've got it set to 330 Celsius. But there it goes. That was a whole lot. Ooh, something smells funny. Something smells funny. I wonder if this is leaked. Blah. They actually smell quite bad. I'm thinking that maybe this cap's gone off and actually leaked a little bit. There's a bit of something. I don't think it's flux, but there's a bit of something underneath it. It's not too good. You might see a bit of a stain on the board just there. Ew, horrible. Let's clean that off and test the capacitor. So we're aiming for 15 microfarads here. Here we go. .7, 3.6. That's all over the place. Let's get my ESR meter. It's going to give me a reading at all? No? Just double checking with the leads. Okay, put the leads back on the cap. Getting no reading. Has a massively high resistance. And just for comparison, I'll do the one in circuit there, which is the same rating. So about 4 ohms there. I don't know if these are low ESR caps. It might be that they aren't, but it's a whole lot better looking though. So let's replace this one if I can and see what happens. Right, I've just pulled this little cap from a laptop motherboard. It's 27 mic at 25 volts. See if I can make it fit in place of the other one, which was only 15 mic, but it won't matter if we make it a bit bigger. Yeah, positive was on the right, so we're going in that way. It does look like it's a bit bigger. Let's see what we can do about that. Now if I rotate it a little bit, rotate it so the positive leg is on, then I can get the negative leg over here, and I can put just a wire link between the two, which should be sufficient. Man, soldering that is nasty. I think I need to wash the board some more. That's absolutely horrible. It smells like cat piss. Actually smells like cat piss. Now, so all I did was I soldered a wire, a little solid core bit of wire, solid strand, from there, ran it under the cap and then tacked it onto the end of the cap on the negative lead over there. So let's get the scope on this and see if it's improved at all. Now, having come from a laptop, I'm sure this will be a low ESR cap. There's the rail in there, all the rails in there are switched, and it was right off the end of a switching FET. Look at the glare on that, bloody hell. Sorry about that, but you can still sort of see it. Right, it's on, here we go. Ah, so much cleaner, and we're sitting at 4.16 volts. So that's a start. That's a really good start. Let's have a look at the output of that chip and see if it's fluctuating like crazy as it was before. Oh, that looks cleaner. Let me get a better shot of that. Look at that. Nice clean sine wave that is being obviously to drive the motor. I'm sure the motor can do a lot more with that than it could that horrible crap that we saw before. Wonderful. Let's plug the motors in and see if they move. Right, I've hooked the flexors back up, and let's try the zooming on this. Here's the my computer desk there. Hey, what do you know? It's working. Yeah, it's excellent. There we are. There's my unsteady hand. And if I zoom out, yep, and it's staying in focus. There we are. Bad power supply, causing the chip to lose its marbles and get confused and not know what it's doing. Now I'm going to wash this board down a bit more because it smelled absolutely horrible, so there's got to be some residue still on there. And we'll put it back together and double check it's all good. Here we go, final test, all back together. Brilliant, look at that. Find your focus, there we go, nice and sharp. Right, we'll call that done. Thanks for watching.